Hello, everyone. Welcome. I'm here with the review for the final. We are going to look at a couple of problems today, and this is the first part of the review for our final exam. So let's begin with our first example. Okay, this question is from the first module of our course. Let's find out what we are asked here and how we can solve it. So this is the easiest question, I should say, because we are not actually doing math here. We are just answering them using a couple of words. Classify the following as discrete or continuous variables. So the first one is number of cups of coffee served at a restaurant. If we think of the number of cups of coffee served at a restaurant, it can be 1 cup, 2 cups, 3 cups, or so on. So that means it's going to be the discrete variable because it's not going to take any decimal values there. So this is the example of discrete. Discrete. Next one, ages of people working in a large factory. If you think of the age can be decimal. Some people will be 42 years, other maybe 36 years and 6 months. Okay. We can also count the days the age in days, hours, and so on. So it's going to take the decimal values there. So the ages of people working in a large factory is an example of continuous variable. Okay, next question here is state the label of measurement for the following. In the first one, we were just checking whether they are discrete or continuous. In the next one, we are looking for label of measurement. When we talk about label of measurement, we are looking at the labels like nominal, ordinal, ratio, or interval. So we are looking for all those things. The first one here is the rating of movies on a scale of 1 through 5. When we talk about the rating of the movies on a scale of 1 through 5, okay, here we are ordering the movies from the list to the highest in terms of how good they are. So that means we are ordering them here. So this is the example of ordinal. Ordinal. Next one, weight of baggage on a commercial airlines. When you talk about the weight, it can be 15 pounds, 20 pounds, or so on, or 22.3 pounds. So it's exact number there. Meaning of that is the weight of baggage on a commercial airline is an example of ratio label of measurement. Ratio. Okay, the last question on the slide here. What are the two main branches of statistics? So if you think of two main branches of statistics, they are descriptive statistics and inferential statistics. So let me write that down. Descriptive and inferential. Descriptive and inferential statistics. Okay, that's our first example. Let's move on to second example. Here is our second example. The stem and leaf plot display the amount of money in dollars spent by Henderson family in their last trip to an amusement park. Use the display to answer the questions that follow. So here is the stem and leaf plot, and we are asked to answer the question based on that. And this represents the amount of money spent by the Henderson family on their 15 trips to the amusement park. First part is, what was the highest amount spent in 230s? So 230s are here, 233, 234, and so on. If you look at the highest amount spent here, it is $239. Next is $239. And then for part B, what was the highest amount spent overall? If you look at the overall data, the highest is $243. $243. And finally, how many amounts fell in 220s? 220s are here, and how many are there? We can count 1, 2, 3, 4, 5, 6. So 6 of them fall under 220. So that's how we can look at the statistical diagram and solve the problem. So this is from our module 2, where we talk about the graphs and display. So here we are looking at the display in the form of a stem and leaf plot. Next question. 5 students spend the following amount in dollars on a day at a shopping at a mall. So these are the values given. We have to find the 5 numbers summary, and then we have to find the outliers, if any. So now, if you want to find the 5 numbers summary, what you have to do is you enter this data in your calculator. Okay, so first thing you do is enter data for the first part. Let me write here. Enter data under L1 in TI-84 calculator. In TI-84 calculator. After that, once you enter the data under L1 in your TI-84 calculator, then go to stat, okay, go to stat and then go to calculate, and then you go to number 1. Number 1, where it says one variable stat. And once you go there, you will see that your list is L1. That's where you have data given. And then there is no frequency. All you have to do is calculate. And from there, you should be able to see your 5 numbers. Okay, please try that in your calculator. And the 5 numbers we are looking for are minimum. That's the first number. Then we want the first quartile Q1. We want the median. We want the third quartile. And we want the maximum. So if you look at your calculator, after you enter the data and you go here, you'll see that the minimum value is 175. Of course, that is true because we have a small data set here. If you quickly look at it, 175 is the minimum. Q1 will be 273. Median will be 489. Third quartile will be 767. And then the maximum value, as you can see here, is 1007. So those are the 5 numbers we are looking for. That is the 5 number summary we want to look at. In the second part, we are asked to find the outliers, if any, using detailed calculation. So in order to find the outlier, we have to see if there are any data value that are outside the boundary. And in order to find those boundary or fences, we need the interquartile range first. So let's begin by calculating the interquartile range. So here, let's see what is our IQR. Here, interquartile range, IQR, which is given by the formula Q3 minus Q1 is equal to Q3 is 767 minus Q1 is 273. And if you perform this, you get 494. Then lower fence will be Q1 minus 1.5 times IQR. That's the formula. Q1 is 273. Then minus 1.5 multiplied to IQR is 494. Q1 is 273. Okay, and then you are subtracting 1.5 times IQR 273. You can type in your calculator and simplify 273 minus 1.5 times 494. And if you do that, you see negative 468. Negative 468. If we have any data value smaller than negative 468, that will be an outlier. But if you look here, we don't have those numbers. So that means we don't have outlier in the lower end. Now let's look at the upper end. For the upper end, we have to find the upper fence, which is Q3 plus 1.5 times IQR. So Q3, as you can see, Q3 is 767 minus 1.5 times IQR is 494, which is equal to, if you simplify it, is 1508. The maximum value is 1007, but here we are getting 1508. That means we don't have any number above that. So technically, there are no outliers. So we say, since none of the data values, none of the data values are outside the fences, okay, there are no outliers. There are no outliers. So that's how we can find the outliers for the given data set. In this one, there are no outliers. If you see any value below the lower boundary or above the upper boundary, in that case, we have the outlier, but in this one, we don't have the outliers. Okay, so that was the third example we did. Let's move on to the next one. Here is the next one. A bag with 12 marble is shown. So you can see the value of n is equal to 12, right? 12 marbles. So n equal to 12. Marble is shown. A marble is chosen at random or chosen from the bag at random. We have to answer the following question by stating the formula. We have to find the probabilities there. But first thing first, if we look at this one carefully, what we see is, let's see the different color balls there. If we want to look at the number of red balls, okay, or red marbles, there are 3 of them, red. Yellow marbles, you can count, you have 4. And the blue marbles, number of blue marbles is equal to 5. Make sure you add these 3 and verify whether it's 12 or not. 3 plus 4 is a 7, plus 5 is a 12. That's correct. So we have 12 marbles there. Now let's try to answer the first part, part A. In part A, we have to find what is the probability that it's a yellow marble. So if you pick a marble at random, what is the probability that it's a yellow marble? Probability of yellow marble is number of yellow marbles divided by the total number of marbles in the bag. So that will be equal to, you can see the probability of yellow will be 4 out of 12. So 4 out of 12. If you reduce this, it is 1/3. Or if you change it to decimal, it is 0.3333 if I go up to 4 decimal places. Okay, that's your first part, A. Now let's find out what is there in part B. In part B, we have to find what is the probability of getting or what is the probability that the marble is a blue or red? Probability of getting a blue or red marble. You can see there is an or means addition rule. And once you see the addition rule, you have to check whether it's mutually inclusive or mutually exclusive. And if you think of these two color marble, a blue marble cannot be red or red cannot be blue. That means they are mutually exclusive. So the formula will be probability of blue plus probability of getting a red. And that is equal to probability of getting blue marble. You can see I have 5 blue marble out of 12. So 5 out of 12 plus the red, you have 3 marble out of 12, which is equal to 8 out of 12, which is same as 2/3 when you reduce that, or as a decimal, it is 0.6667 when you go to 4 decimal places. So you can clearly see we are asked to state the formula and we are asked to use the formula, right? State and use the formula to find the probabilities. And we did that. In first part, also we wrote the formula, and also in the second part, we wrote the formula. And we use that formula to find the probability. Okay, this is the question from our 4th module. Now let's move on to next one. The next question will be from our 5th module. Okay, here is the next one. And let's see what is given here. A weighted cube has a face label 1 through 6. If it is a fair cube with all sides, the probability of appearing all side equal, the probabilities will be equal. But here it's a weighted cube, so probability of getting 1, 2, 3, 4, 5, 6, all these numbers are different here. But remember, still these probabilities are the numbers between 0 and 1, and the total probability must be 1. That's true here. Let X be the number shown on the cube when it is rolled. Below is the probability distribution of X. So the discrete probability distribution is given here. We have to find the probability that the number described is shown on a roll is greater than or equal to 4 or at most 4. So there are 2 parts there. So for the first part, part A, we have to find the probability that X, the number, is greater than or equal to 4. Okay. greater than or equal to 4. So because it is a OR, it is the addition rule. So probability that x equal to 4 plus probability that x is equal to 5 plus probability that x is equal to 6. We write the formula for OR, addition rule for probability. Probability that x equal to 4 is 0.15. Probability of getting 5 is 0.12. And probability of getting 6 is 0.11. And if you add these three, you will get 0.38. So probability of getting a number which is 4 or more is 0.38. Now let's look at B. In B, we have to find the probability of getting a number that is at most 3, maximum of 3. That means you can get a 1, 2, or 3. So this is same as, at most 3 is same as probability of getting a number which is less than or equal to 3. That is the meaning. So again, this is a OR. So we can write the addition rule, probability of getting 1 plus probability of getting 2 plus probability of getting 3. You can get a maximum of 3, at most 3. We go up to 3. Probability of getting 1 is 0.18. Probability of getting 2 is 0.28. Probability of getting 3 is 0.16. And if we add all these, it will be 0.62. So this is how we can find the probabilities when the discrete probability distribution is given to you. You can look at the table and then you can write those corresponding probabilities, use the proper formula. In this case, it's OR. At most means that is less than or equal to 3. So we use the or addition rule of probability and found those values. Okay, now let's go to the next example. Look like this is from our 6th module, normal distribution. Suppose Z follows the standard normal distribution. Using TI-84 calculator or use TI-84 calculator to determine the value of C such that probability that Z lies between -2 and C is 0.135. So let's see how we can do that. Okay, so first we are going to draw that distribution. So let's quickly draw the distribution. So this is the normal distribution, standard normal distribution. So Z, okay, Z follows the standard normal distribution, meaning mean is 0 and standard deviation is 1. So 0 lies here in the middle. Now the probability that Z, so these values along the x-axis, is between -2 and C is 0.135. So -2, if you think of -2 should be, okay, if you think of 1, 2 is standard deviation, so 2 should be somewhere there. So that should be -2. So probability that the Z value is between -2 and C is 0.135, like 13.5% area. So the 13.5% area should be something like that. So if that is C, okay, if that is C, then this area here is 0.135. Okay, 0.135. Now, what we are asked to do is we are asked to find the value of this C. Okay, value of this C. So what we know is, we know this. Let me write it down. C is equal to, if we want to find the value along the x-axis, we use inverse normal. So this will be inverse normal. And then area to the left of C. You can see the area to the left of C is required. So let me write area to the left is required. And then we need the mean and the standard deviation. But if you look at the diagram carefully, area to the left of C is not there. We just have area from here to here. We are missing this much area. See, we are missing that area in red. If we know that area, then we can easily find the total area to the left of C, and we can plug in here to find the value. So first of all, I need to find the area to the left of -2. So let's do that. So area to the left of -2 is, so to find the area or probability, we use normal CDF. So let's use normal CDF. Lower boundary for this area in red is -infinity, -E99. Okay. Upper boundary is -2. Mean is 0. Standard deviation is 1. And if we simplify this using calculator, you should get 0.0228. So that area in red is 0.0228. So now, once you know that area in red, we can find the total area to the left of C. So let's write that down. Total area to the left of C. Total area to the left of C. To the left of C is, so if you look at the diagram, to the left of C, we have 0.135 first, 0.135 in that section that is given. And then to the tail, we have 0.0228. And if we add these two values, the total area will be, if you add those two values, okay, we can add, the total value will be 0.1578. There we go. So once we have this total area, now we can plug into this equation. Okay, we can plug into that equation and find the value of C. So let me write that down. Hence, C is given by this formula, which is equal to inverse normal. Now we know that area to the left. Area to the left is 0.1578. 0.1578, mean is 0, standard deviation is 1. Now, remember one thing, if this area is 13.15 or 0.135 or 13.5%, the C must be on the left of 0. That means the answer that we are getting here must be a negative value. So if we type this in our calculator to check it, okay, you can try this. What we get is -1.0035. So the value of C is -1.0035. So that's how we can find the value of value of C. Remember, whenever we want to find the values along the x-axis, we have to use the inverse normal, and we need area to the left. And you have to check whether the total area to the left is there or not. If the total area to the left of that value is not there, you have to first find that total area to the left, then only you can use that inverse normal to get the value. Okay, so that is the end of the first part of our review for the final exam. I hope you'll be able to do well on your final exam, and good luck for that. That's all for now. Have fun. Bye.